Hello, I'm Srivadan. I'm currently working as AML Development at Modi.
Hello, I am Parid Modi. I am co-founder of Book My Paper and I am previously incubated at Product Consultancy.
Myself Karan Patel and I am AI and CV intern at Orange Labs.
Hi, this is Viren. I work as an AI/ML engineer at Webocal Technologies and previously I worked at CCL IIT Gandhinagar. We are Team ARJUN and we are here to present our solution to the critical safety challenges faced in crane and construction operations. Every lift matters, every life matters, and safety cannot be an afterthought. The idea of our platform is to bring predictive safety and collision avoidance to the cranes using computer vision and smart sensing technologies. Over the past month, we have visited multiple construction sites and engaged with construction managers to understand the real challenges faced by them daily. Their insights reinforce the urgency of addressing the safety risks in the crane operations. A moment of safety prevents a lifetime of regret. The problem we are solving is the absence of real-time intelligent safety systems in crane operations. Cranes often operate in crowded and complex environments with limited operator visibility, unpredicted obstacles, and continuous human activity. This leads to serious risks, collisions, falling objects, electrical hazards, and unstable loads, all of which can endanger life and disrupt projects. From our discussions, we found that today's industry struggles with operator blind spots, uncontrolled load swing, risk of object drops, and lack of predictive collision warnings, especially when multiple cranes are working in close proximity. These challenges not only increase the accident risks but also slow down the projects and raise the operational costs. In construction, progress should never come with the cost of safety. We all know that cranes are critical to construction, whether it is lifting structures, transporting materials, or supplying essential tasks. But overlapping crane zones, tight schedules, and planning complexity often create conflicts and safety hazards on site. Smart safety isn't just an option, it's the future of construction. Over the last 10 years, 249 crane incidents resulted in 838 OSHA violations, leading to 2.3 million in fines and severe injury or fatality costs. The main cause of crane accidents include crushed loads, dropped loads, falls, and improper lockout practices. 93% of overhead crane accidents are fatal, emphasizing the need for a stricter global safety measure. Globally, 44 crane-related fatalities per year occur, mainly due to transportation errors, falls, and equipment strikes. In India, violations of IS 4573, which is covering construction, inspection and maintenance, and IS 3177, focusing on safety devices and operator training, are common, leading to unsafe operations. Implementing comprehensive safety measures and ensuring strict adherence to these regulations can significantly reduce crane-related hazards. Regular inspections and proper training are crucial to mitigate risks and ensure safe work environments. By ensuring these vulnerabilities, we can protect lives and prevent costly accidents. Our proposed solution aims to address these challenges by integrating advanced sensors and real-time monitoring. Our system will reduce injuries, minimize financial losses, and operational downtime. Now let us take you through our solution in action and showcase the prototypes we have developed to make crane operations smarter and safer.
So let us start with our basic workflow of how our collision avoidance system will work.
So the next feature in our solution is holographic geofencing for crane safety. In this solution, a holographic projection is made on the floor above which the load is present. This is specially for EOT based cranes which are inside the factory and they move in X, Y and Z directions. The features include downward facing laser projector activation, holographic boundary, visual safety zone screen. The next feature in this solution is AI powered image recognition. Now moving on to AI powered image recognition for crane safety and collision avoidance. Cameras integrated with advanced computer vision algorithms can detect and classify various objects in real time, including workers, equipment, and crane components. This continuous monitoring helps in identifying potential risks in dynamic environments and supports proactive safety measures. Two major challenges we address here are: first, swaying loads. During lifting operations, large loads tend to sway and this motion can create critical hazards, putting individuals in danger of being stuck. Second, object drops. Operating overhead cranes comes with a serious risk of accidental object falls, which can lead to severe injuries or even fatalities if personnel are present below. To tackle these issues, we have developed two prototypes. In prototype 1, we developed the presence of personnel directly in crane's danger zone from an overhead camera, and we detect this, issuing real-time alerts to prevent accidents. In the second prototype, we detect both crane hook and nearby individuals simultaneously, helping to predict and avoid possible collisions in advance in case of tower cranes, as well as EOT-based cranes. This AI-based solutions aims to create safer industrial crane operations through continuous monitoring and timely alerts. For detecting both persons and crane hooks, we used YOLO V8, which is one of the most advanced object detection model available today. It's widely recognized for its real-time performance and excellent accuracy, making it ideal for safety and critical environments like crane operations. The architecture of YOLO V8 consists of three main components: the backbone, the neck, and the head. The backbone, which comprises of CSP darknet to extract strong and meaningful features from the images. The neck, built with a PNet and FPN layers, allows model to detect objects at multiple scales, whether they are small or large. And finally, the head, which predicts the bounding boxes, confidence scores, and class probabilities quickly and efficiently. For the model training, we use around 3,500 annotated images collected from various construction and industrial sites, focused on specifically two classes. The first one is person and the second one is crane hook. These images were carefully labeled and the model was fine-tuned for both accuracy and speed, ensuring it performs reliably on real-world dynamic environments. So this is the RoboFlow dataset that we have used to train the model. We manually annotated all the persons and crane hooks in the dataset. The cameras which we use for first prototype are overhead cameras, as well as the ones that we use for second prototype are side angle cameras present in the factories itself. For the live feed, we have used these high resolution IP cameras with a wide angle lens, ensuring clear coverage of the crane surrounding for accurate detection. So in the embedded device, they provide a lot of functionality and advantages, including CCTV integration, edge AI processing, collision risk assessment, immediate alerts, data transmission, and analysis. We mainly use these devices for real-time on-edge inference. They provide a very low latency using energy efficient and compact mechanism. So this is the detection pipeline used in our prototype, where we start by getting the CCTV feed from the cameras which are mounted either on the crane or in the factory for EOT based cranes. These video streams are sent to embedded AI devices like NVIDIA Jetson Nano or Orin, which where real-time object detection models such as YOLO V8 run locally to identify workers, crane components, and obstacles. The system then calculates the proximity, predicts trajectories, and identifies potential collision risks based on object positions and movements. If any unsafe condition or collision is probability detected, then immediate alerts are triggered through visual signals, alarms, and notifications on a centralized dashboard. Additionally, the system wirelessly transmits all detection logs and the events to a dashboard for live monitoring and historical analysis, enabling data-driven safety improvements and trajectory planning optimization.
While using cameras and sensors, it is very significant to decide their location for precise monitoring. Strategic placement ensures maximum coverage, safety, and efficiency in crane operations. First, jib and Lidar with cameras provide 360-degree awareness. Lidar helps detect obstacles, track load positions, and offer depth perception, while cameras give operators real-time visuals, especially in blind spots. Together, they enhance collision prevention, improve visibility, and ensure safe operations in all lighting conditions. Next, external cameras cover the entire construction site, providing a wider field of view. These cameras work alongside the Lidar to create accurate depth maps and recognize objects. They also support remote operation and safety compliance, ensuring a well-monitored and controlled worksite.
Proximity and monitoring is one of the features for which we have proposed the solution. The proximity and monitoring system provides an essential layer of safety and control by continuously measuring the distance between the crane and its surrounding barriers. Using sensors, it ensures precise spatial awareness, thereby helping operators make informed decisions in real time. At the heart of this system are LiDAR sensors, which generate accurate 3D representation of crane's environment. This detailed mapping enables operators to visualize potential obstructions, including nearby structures and materials, ensuring safety maneuvering at every stage of operations. In scenarios where objects are positioned very close to the crane, ultrasonic sensors come into the play. Their narrow detection range proves particularly useful for detection obstacles at short distance, helping prevent accidental collisions. By integrating this sensor into unified monitoring frameworks, the system continuously analyzes incoming data, triggering timely alarm and warnings when a hazard is detected. Furthermore, real-time data analysis enabled proactive adjustment and automatic responses, thereby reducing human error and enhancing overall operational efficiency. Through its comprehensive proximity detection and monitoring capabilities, this system significantly minimizes collision risk and reinforces a safer working environment for both personnel and equipment. Our proximity and monitoring solution incorporates a two-leveled approach for object detection using both TF Luna sensors and Lidar. The first level utilizes TF Luna sensors enhanced with electromagnetic and infrared frequencies to cover a range of 30 meter to 60 meter. These sensors are strategically installed along the horizontal bar boom of the tower crane, enabling detection of objects in overlapping areas or those very close to the crane. This layer ensures immediate alerts when object encroaches within a critical proximity. The second level is powered by Lidar, which provides a comprehensive 3D mapping of the surrounding environment. This high fidelity mapping offers unparalleled depth, precision, and spatial awareness, supporting robust hazard detection beyond the short-range capability of TF Luna sensors. By combining these two layers, short-range multi-point proximity detection with TF Luna and wide-range detailed environmental mapping with Lidar, our system forms a comprehensive shield against potential accidents. This dual-layer approach not only maximizes safety by ensuring timely alerts, but also enhances overall operational efficiency in crane operations.
In this video, you can see our working prototype where an object is moving within a defined lane. Along with its movement, we are showcasing the LiDAR output in real time. The LiDAR sensor continuously scans the vicinity, detecting nearby objects and mapping their positions. This allows us to visualize potential collision risks clearly. At the bottom, you can see live camera feed, while the main screen displays LiDAR contours highlighting obstacles. This fusion enhances 360-degree awareness, ensuring safer crane operations by detecting collisions beyond camera blind spots.
In high-demand industrial environments, multiple cranes working together can often lead to operational bottlenecks, unexpected delays, and most critically, safety risks. Traditional crane management systems rely heavily on manual coordination, leaving room for errors, inefficiencies, and potential collisions. To solve these challenges, we propose an intelligent system that revolutionizes crane operations by combining real-time monitoring, adaptive scheduling, and AI-driven safety measures. Our goal is to ensure that cranes work seamlessly, efficiently, and without risk, even in crowded multi-crane environments. At the core of our solution is priority-based scheduling, which ensures that most critical tasks are handled first while continuously monitoring crane positions and loads. The system operates in two states. First is safe state. Cranes can operate normally without any restrictions, and second is unsafe state. A risk of collision or interference is detected, the system immediately alerts the operator and suggests a way to return to a safe state. To prevent unsafe conditions, our system provides alternate movement paths. Instead of stopping operations completely, the system evaluates if a crane can approach the task from another direction. And second is height hour monitoring. Since cranes often operate at different elevations, overlapping movements can pose a risk. Cameras mounted at the end of the jeep provide a real-time height feedback, ensuring safe clearance. If neither an alternative path or height adjustment resolves the issue, our system automatically adjusts scheduling, pausing one crane while allowing the other to complete its task safely. The balance between real-time decision making and scheduling logic ensures uninterrupted operations while prioritizing safety. By integrating real-time hazard detection, intelligent rerouting, and dynamic scheduling, our system takes multiple crane operations to the next level, safer, more efficient, and future-ready.
So this is the prototype that we have developed for geofencing using Python. So here we upload an aerial image of a construction site, and then we plot the restricted areas, which can be some residential areas or buildings, to avoid any possible accidents. So we are marking a total of 3 restricted areas. So this can be done by ground operators and can be monitors as well. The center 2 circles are for the cranes. The left one is blue and right is given a green crane. Here you can see that the cranes can be rotated in every possible directions. However, they cannot enter in the red zones as they are restricted areas, and when a crane tries to enter, the alert is generated. Also, when 2 cranes get very close to each other, the proximity warning is displayed as well. Here is the proximity warning as well.
Load sway is a major challenge in tower crane operations. It occurs when the suspended load swings like pendulum due to inertia, stops sudden, changes in direction, or due to external forces like winds. Uncontrolled sway can lead to collisions, load mismanagement, safety risks for ground workers, as well as equipments. To detect swings, inclinometers are used. This measures the radial swing angle alpha and the rotational swing angle beta to track the movement. Programmable logic controllers process the sensor data and adjust the crane movements using real-time feedback control. By continuously adjusting the motor torques, the trolley speeds based on the real-time feedback, PLC enhance the stability and the precision of the crane operations. To stop load sway efficiently, techniques like trajectory planning, adaptive control, and virtual spring mass systems are implemented. We use the artificial intelligence to predict and counter swing. The best control strategies can eliminate sway within 6 to 8 seconds, while traditional methods may take 10 to 15 seconds or longer. Without proper control, swing can persist for 30 seconds or long. Increasing the risk of accidents, this solution ensures smoother, safer, and more efficient crane operations. Now we will see a crane movement without sway control and with sway control to understand the difference, and also the fundamentals that we will be using in our prototyping to make sure that the sway controls doesn't happen for much longer period.
So in our platform, data logging plays a crucial role in improving safety and efficiency. First, in our AI-based detection prototype, we log crane hook trajectories, load movements, and human detections to analyze patterns and improve accuracy. Second, in our multi-crane collision prevention system, we record crane positions and movements to visualize paths and avoid conflicts. And third, through Lidar monitoring, we log obstacle detections and near miss events, enabling continuous safety audits and smarter predictive algorithms for future operations.
Our tech stack starts with proximity monitoring, employing advanced sensors such as Lidar and ultrasonic technology to maintain a vigilant watch over crane surroundings. By continuously measuring and distances, it swiftly identifies nearby obstacles, ensuring collisions are prevented in the real time. Next, AI-powered detections uses real-time image recognition to detect people and crane hooks and equipments, enabling safer and more efficient operations. Building upon that is our crane scheduling algorithm, which draws on the principle of the basic and fundamental compiler designing and microprocessor scheduling to prevent crane movement, coordinate tasks, and reduce collisions risk across multiple cranes. Operators interact with these features through a user-friendly dashboard, offering clear, real-time information without complicated charts. Visual and the audio cues are also supported, ensuring swift response to multiple and potential hazards and minimizing stress in a very fast-paced environment. Moreover, our system is built with the scalability in the mind, effectively managing operations for multiple cranes across expansive work sites. And finally, data logging, which is very important task, is continuously record and the safety events and the operational metrics on a secure cloud server, providing immediate insights for decision making and fostering continuous improvements in crane safety. So this is our whole idea of the tech stack that we will be using in our prototyping. Our crane safety brings significant improvements to crane operators, with safety as our top priority. By detecting people in hazardous zones and monitoring distances, we help prevent injuries and reduce the risk of accidents by 45%. Our system also identifies obstacles to prevent collisions, addressing one of the leading causes of the crane-related accidents. Beyond safety, we optimize crane movements by detecting load types and calculating their positions. This can reduce unnecessary lifts by 40% and shorten the project timelines by around 20%, leading to operational cost savings of approximately 15%. To further support operators, we have developed an interactive GUI that provides a clear view of crane movements and highlights the potential collision zones. This improves decision making and reduces human error by 25%, With this advancement, our system ensures safer, more efficient, and cost effective crane operations throughout the construction timelines. Thank you.
Now, let us talk about the future vision for the platform. First, cross-industry adoption. While we currently focus on tower and EOT cranes, our solution is designed to scale. Globally, over 150,000 cranes operate across shipping ports, manufacturing plants, and warehouses. By offering industry-specific safety modules, we can help reduce accident rates in these sectors, where crane-related incidents account for nearly 20% of workspace fatalities in heavy industries. Next, third-party integration. We plan to enable API support for integration with crane management and ERP systems. Studies show that companies with integrated safety monitoring experience up to 30% faster incident response from and reduction in downtime. Compliance and report is also another critical focus. Construction and industrial audits often lead to costly penalties, with over 100 million in crane safety related fines issued globally each year. Our automated reporting will ensure adherence to regional standards and streamlining safety inspections. Finally, AI model personalization will make our system smarter over time. With continuous learning from real-world data and operator feedback, we aim to reduce false alarms and improve detection accuracy beyond 95%, ensuring safer and more intelligent crane operations. This enhancement positions our solution at not just as a safety tool, but as an adaptive intelligent system ready for cross-industry impact.